Hi, good evening, everyone. So today's session is on built-in function. So from today we'll be starting that built-in functions. Today is the part one, and then gradually you will learn a lot of built-in functions. Meanwhile, if you have any queries, you can type in the chat box because you'll be starting the session in next 2 minutes. And we have already shared that link for Skype group where you can attend daily at 6:30 to discuss all of your queries. So I hope you all are doing your assignments. If not, then please start doing it. We have uploaded the new version of assignments and the study material. So please start doing that. And in case you have any queries, you can attend that Skype group link and ask your queries there. I'll share the Skype group link again. People who don't have Skype group link, I have typed in the chat box. And all the study material link is already being provided in the emails. So you can refer it from there. You can type again if you don't have. This is the link for self-study material. I'm typing in the chat box so you can save it. And we'll start in just in next 1 minute. In case you have any queries, you can type here in the chat box. For any programming related queries, you can discuss in the Skype group daily at 6:30. You can join there. Do not type your questions in that Skype group link. You can directly join at 6:30. Daily, we are sharing the link there where you can discuss all of your queries. And even you don't have queries, we would still suggest you to join that and that Skype group because maybe you are not facing it today, you can face it tomorrow. So at least you know what was the problem and how to solve that problem. So it would help you in learning new things. Okay, so now we are starting with the session. Yeah, Himanshu, let's go ahead.
So, hi team. Today we will learn about the built-in function in RPGLE and some hands-on practice and programs on built-in functions. And we will take the queries on the session after the session. So now I am starting the session.
And for the built-in functions, like we will be covering various built-in functions that are available in IBMi. And what built-in function is? Built-in function is a inbuilt programs that are written inside our IBMi system, and once we use that built-in function, that program is being called and it returns its value. So uh, we don't have to write those programs or that particular function in our program, and we can directly use that particular function so that we can get the result that we wanted from that particular function. So I'll be showing you all those built-in functions that are available in IBMi. So I will be sharing my screen. Natik, is my screen visible?
Yes, sir, it's visible.
Okay, so I'm starting with my program that I have written to show you how the built-in function will be working. So the first built-in functions that is available with us in IBMi is percentile ABS. And first of all the built-in functions that are available with us in IBMi will start with percentile sign with it. Okay, then its name, and after that in the brackets there can be the parameter that is it wants to execute that particular function. So first built-in function is percentile abs, and it is for the absolute value, to get the absolute value of a uh, you can say the calculation. Let's suppose over here we are having sell price as 250 and the buy price as 340. So the result of this expression is minus 90. But what percentile abs function will do, it will convert that negative value into a positive value. Okay, so this function can be used uh, when you want to show on the screen only the positive value, like if there is any loss of something and you wanted to show in this particular month the company has uh, got these many loss, so you can use that percentile abs function to convert that particular negative value into positive. So over here we were getting the negative 90 result, but I have used the percentile abs function. So if I will execute this statement and check the value of loss, so it is showing us that value of that particular variable is 90, you can see here. So you can use this percentile abs function to get a positive value of an expression. So whether the expression is negative or positive, it will always give you the positive result. So moving on to the next built-in function, which is percentile care, and it is used to convert a numeric value into character, or you can use it to convert any date, time, timestamp value into a character value, so that you can use that particular character value and you can do, like if there is a date in that particular character variable and you want to just substring year, month and date, so you can just use that substring function next to that particular function and you can do that. So the syntax for that is like percentile care will assume to get a variable, like a variable that can be a numeric value or a date, time or timestamp variable. And next is the format. Format is basically used only with time, date and timestamp variable, so that this function can understand in which particular format that particular date, time and timestamp is. Okay, so here that loss is a numeric variable, and currently I have value of that is 90, you can check over here. And output is a character variable, and once I will use that percentile care built-in function and I have passed this particular parameter to it, which is of type numeric, and once I will execute this statement, the uh, result of this particular statement will come into this output variable. And if you will see the result of output, it's in character and its value is 90. So you can use this built-in function to convert numeric value into character. Next, I have shown here examples to how we can use date to convert that particular date into a character. So here in this particular function, I am getting the current date. In the date one variable, we got the current date. And here I'm converting that date variable into a character variable by using the built-in function percentile care. So after executing this statement, I got the result as this 2020 12/28, and you can see this is a character variable, and we got that date variable converted into the character value, and we have stored that value into our output variable. Next is this function, in which we are telling in which particular format we want to convert our date variable. Like here we had the value of date as in star ISO format, which is 2020, then month, then date. And I want to convert first that particular date into MMDDYY format, and then want to store that into output variable. So to do that, I have passed the second parameter, which is format as star MDY. So it will convert that particular date into MMDDYY format, and this percentile care will then convert that particular result into the character variable, that particular date. So we got the result as month, then date, then year. And we have, like, these are the most commonly used date formats. You can also check those on IBMi's website, like the star YMD format, and it is like format is YYMMDD. Star DMY format, it store the data as DD YY. Star ISO format, in which date is stored as YYMMDD. And star USA format, in which date is stored as MMDD and YYYY format. So these are most commonly used date formats, and there are some others as well. So you can check those as well. Moving on to the next built-in function, which is percentile check. And percentile check built-in function is similar to the opcode check. Okay, and we have gone through that particular opcode in the previous session. So it also functions the same, like percentile check. It also works the same way as opcode check does. And its syntax is like, first is the comparator. In the comparator, we have to pass uh, the values that we want to check in the base string. Base string is the string that we have to pass, and in which we want to check, like, these comparator values should not exist in that particular string. And at the position where that particular character does not found, that will be stored in our, it will be returned into the position variable. And we can also give the starting position from where we want to start that particular uh, s- we want to start the comparison of the that particular base string. Like in the base string, if we have 10 characters and we want to start comparing from the fifth character, so we can pass the starting position as well. And percentile check is like, it will return us the non occurrence of a character. Let's suppose in the comparator, in this example, I have passed blank. So I want to check here the non occurrence of blank in this particular string. So the non occurrence of blank is present at this position. So this particular function percentile check will return me this particular position into this position variable. So if I will execute this name statement, you can see over here, this is the value of name. And in this particular statement, I'm checking the non-occurrence of blanks in this variable. So if I will execute this statement and then check the value of position, I got position 8. Okay. And I have used, like, just to show it is speaking from here only, I have used the percentage substring built-in function to get the 5 characters from the 8th position. So you can see over here in the name one, I got these 5 characters PRAVE. It has started from P and it has taken the 5 characters. So we can check the non-occurrence of one character, and also if you want to check non-occurrence of multiple characters, that also be done by using this percentile check built-in function, and that I have shown in this particular example. Over here I am checking the non-occurrence of characters blank 1, 2 and 3. So the percentile check built-in function will check all these characters into the base string, and at whatever position, if it doesn't found any of these characters, then it will return that particular position to us, and we can use that particular position. So in this example, let me execute this statement, and in the name variable we are having value as this. And once I will execute this statement, we will get the position, and in position this function will return as the position of v. So in the position we get 11. So 11 is the position of v. So we can use that particular position in a way if we have that kind of requirement. And so next built-in function is percentile check r, which is exactly the same as percentile check built-in function, but it will start comparing the comparator characters into the base string from the right side. Otherwise it is also doing the same, like it is also checking the non-occurrence of a character into a string. Now let's see the result over here for this particular built-in function. In the name variable I have stored this variable Praveen Rana, and now I'm checking the blank, checking the non-occurrence of blank in name. And if you will see the variable name, it is having these values, and you can see this a is mm, let me show you the length as well of this particular variable. It is of 30 characters. Okay, so in 30 it will return as the position of a, and it will start checking from the right side. So if I will execute this particular statement, we will get the position as 19, means that particular a is coming at the 19th position. Okay. Also that percentile check r can also be used to check the non-occurrence of multiple characters, and just the only difference from percentile check r and percentile check is that it will start the comparison of string from the right side only. Otherwise these both are same. So let's see the result over here. Here I have stored the value in name as this particular string, and I want to get the position of non-occurrence of blank 1, 2 and 3. So once I will execute this statement, I will get the value 19 in position variable, and if you will see, the it has returned the position of a over here as well. So you can use this built-in function as well whenever you want to uh, check the non-occurrence of one character as well as a set of characters, then you can use this built-in function. So moving on to the next built-in function, which is percentile date. And percentile date built-in function is used to convert a numeric or a character value into a date kind of date data type variable. So you can use if you want to like convert a character or a numeric value into a date type of variable, and you want to store that particular value in a date kind of variable, then you can do that by using this percentile date built-in function. And I have shown you the examples over here. And if one more function of this percentile date built-in function is, if you are not passing any parameter to this particular built-in function, then it will return the current date of the system to you. So after executing this particular statement, we get the current date into the variable today. So in today variable, you can see over here, I got the today's date. Okay, so first function was that. Second is, now I'm converting this variable w date. In w date, I have stored value 2017 0501. Now I want to convert that into a date kind of value. And in my date currently I am having this value. So after executing this particular statement, percentile date will convert this variable into a date type, and it will store the value into this my date. So after executing this particular statement, you can check in the my date variable, we got this 2017, 05 and 01, and it is of type date now. Also, uh, we can also pass the format to, like we want to tell the system like in which particular format we have passed the date, so that it will convert in that way itself. Like I'm passing here star mdy format, so this percentile date function will assume this date as in the format of mmddyy. And once I will execute this, it will store this as 2007 as 17 as year, then 03 as month, and 01 as date. And if you will see in w date 1, we had value as 03 month, then 01 date, then 17 as year. You can see this format, and I have shown this format to you. And next is also uh, this 0 after the format specifies, like if you don't um, want to use those separators, these are called separators, which are separating the year, month and date. Sorry, this is like the format that you have passed, for that it is expecting that particular format. So this is the function of percentile date. Now moving on to the next built-in functions, percentile days, percentile months, and percentile years. We can use these particular functions whenever we want to do some calculation over date. Like if you want to subtract some days, or add some months, or add some years in a date type of variable, then you can do directly, you can do that directly, calculating like my date equal to today's date, then minus 1, then it won't like it it will expect that particular second part into a kind of function. Like over here I have converted that particular variable into first days, and then I am subtracting, so that it will easily subtract that and store that value into the right hand side variable, left hand side variable. So here in the today's variable, I have the today's date. Now I am subtracting 1 day from it, and I am getting the result as this 27th of December. Okay. Now if we want to subtract 2 months from the today's date, then we can use the built-in function star months to convert that particular duration into months, and then we can subtract that from the today's date. If I will execute this statement, you can see the result of my date variable. It is showing us this 10th month of the year. Now next is the built-in function percentile years. It will convert that particular duration into years first, and then it will subtract, then we can use that particular duration to subtract that from a date kind of variable, and then store its value into my date variable. So here, after executing this statement, we will get the year as 2016, as we have subtracted 4 years from the current year. Moving on to the next built-in function, which is percentile DEC, and this is the syntax of this percentile DEC built-in function. The parameters that it requires is date, time, or timestamp, and then its format, and also percentile DEC built-in function can be used to convert a date, uh, convert those date, time, or timestamp variables into a numeric value. So let's see over here. In the today's variable, we are having value as today's date. Now I'm using percentile DEC built-in function, and I want to store the result into today num. So after executing this statement, you can see in the today num variable, we got the result as 20201228, and it's a number. If you want to see that the data type of today num, it's numeric. Over here, I have declared it as 8p0. Next is this. We can also pass the format, in which particular format the date is, and after executing that variable, that particular statement, we will get the result. Like here, I have passed like in which particular format I want to convert that date is YYMMDD. So in the result, we got 20 as year, and 12 as month, and 28 as date. And in today we had value as year in 4 digits, but in the result, as we have converted it in the different format like star ymd, which stores the date in 2 digit year as YYMMDD. So in the today num, if you will see the result, we got only 20 part of the year. So you can use this percentile DEC uh, built-in function to convert those dates, time, timestamp kind of variables into numeric kind of variables. Also, this percentile DEC function can also be used to convert the a character variable into numeric, but it should have all numbers into it. Okay, so its syntax for this is the numeric expression that is stored as a character, then digits uh, that we are expecting before that decimal point, and after that it is expecting how many digits are there after decimal. So here I have passed the value as minus 2017.28, and I have stored it in our character variable. And now I want to convert that character variable into a numeric value of 7 2. If I will show you, there's the data type and length of variable DEC01. You can check over here. DEC001 is declared as 7s2. So now this char 001 is converted into a numeric value after this statement, as we have used the built-in function percentile DEC, and you can check the value of DEC001. It's in numeric form and its value is 2017.28. Now in the second example, I have converted this character variable into a numeric of 7 1. Means after the decimal point, I want to just get one character. So it will store the result as 2017.2 only. You can see the result. It has shown as negative 002017.2. So we can use this particular built-in functions to convert like a character variable. If that particular character variable is having all the digits, then you can convert that particular character into a numeric by using this percentile DEC built-in function. Okay, moving on to the next built-in function, which is percentile diff. Percentile diff built-in function will give us the difference of two either dates, time, or timestamps, and the format in which we want to get the results. These are the formats in which it can give us the results. Like if we are having the both these op1 and op2 as dates, then we can receive our results in percent star days, star month, or star year. And if it is time or timestamp, then we can get the results into minutes, hours, or seconds. So in that way we can get the difference of either two dates, two times. So moving on to this example of this particular built-in function, over here we have date one value as 28th of December and date 2 as 20 as value as 8th of November. And here I want the difference in the form of days. So once I will execute this statement, the difference of the days will be stored in my this variable. So the value is the difference of both the dates is 50 days. So I have stored this value in days diff variable. Now I have given one example of the difference of times. Here time 1 is 12:51:57 and time 2 is 11:50:57. So after this particular statement, we will be storing the difference of time 1 and time 2 in minutes form in time diff variable, and we can check the value as the time difference is of 61 minutes. So this is the function of this built-in function percentile diff that can be used to get the difference of either two dates or two times, or there can be two timestamps as well. So moving on to the next built-in function, which is percentile edit C. This built-in function is being used to uh, like show a numeric value into some kind of format that that directly cannot be stored, and for that we have to pass it the numeric value that we want to convert in that particular format. Here edit code will specify in which particular format we want to convert that, but we want to show that numeric value. And these are three symbol. These this third parameter is like star asterisk fill. Like if we want to fill the zeros zeros with the star asterisk or by some currency symbol. I have shown you it that in example, so you can be that can be more clear by seeing that. So let's suppose over here I have input 1 as 0, 1, 2, 3, 4, 5, 6, input 2 as negative 1, 2, 3, 4, 5, 6, input 3 as 1, 2, 3, 4 dot 5, 6, input 4 as 1, 2, 3, 4 dot 5, 6, which is negative, and I am using the edit code as 1 in all of these, and I want to store those results into a character variable. So I'm concatenating these all the values, and then I'm converting that and storing the value in edit code. So after executing this statement, if you will see here, it has shown that particular 1 2 3 4 5 6 variable as 1 2 3 then comma 4 5 6. Second one is also the same. In the third one, it has shown us 1 comma 2 3 4 then dot 5 6. And as these were negatives, but this edit code 1 shows us only the doesn't show the negative sign. Hmm. I'm sharing my screen to show you the results of these built-in that built-in functions edit codes. So I have used the edit code 1 here. So in that particular edit code, what it does with that numeric value is first one comma displayed, yes, so it will display the commas. Decimal point displayed, yes, it will show the decimal point as well. Is negative sign displayed? No sign. Means if there is a negative value, it won't show the sign of that particular numeric value. Leading zeros suppressed? Yes. Means if there are leading zeros, so it will suppress those zeros. It won't show those zeros. So you can use all of these edit codes, and here it's that edit codes functionalities, like whether the commas will be displayed, whether the decimal point will be displayed or not, whether the negative sign is displayed or not, or if the leading zeros are suppressed or not. So you can use these particular edit codes with that numeric value, and it will show that particular numeric value in that particular format. So you can use these. Okay, now here I have used the edit code k, and if you will see over here, edit code k, comma displayed yes, decimal point displayed yes, minus sign will come on the right of that particular variable, and leading zero suppressed yes. And I have also given here star asterisk fill, so all these zeros will be filled with asterisk. See over here the result, all the zeros will be filled with those asterisks, and the negative sign is coming on the right side of the value, which is the function of this edit code k. Now I have used that third parameter as currency symbol, so it will add the currency symbol in that particular value. So after executing this statement, we will get the value as $9 then comma 234.87 and then the negative sign. So here that currency symbol dollar is being used. So we can use these edit codes to show these, like the dollar sign, or whether we want that negative sign in the left side or the right side, or whether we want to display those commas or not. So in those cases we can use these edit codes. Okay, so after the percentile edit C, built-in function, we are moving on to the next built-in function, which is percentile ELEM, which returns us the number of elements that can be stored in a array or a multi-occurrence data structure. Like if you don't want to like hard code that particular thing, like how many number of variables are stored in that particular array, how many values are stored in that particular array, or the dimension of that array. So you can just directly use this built-in function percentile element, and it will give you the dimension of that particular array, like how many variables, how many values you can store in that particular array. So if I will show you here, the array 001 is having dimension 8, means we can store 8 values in this particular array. So after executing this particular statement, percentile elim ARR001, we can get that particular value or the dimension of that array into that particular variable, and we can use that particular value in our program. Like we want to execute some loop to the number of times that the dimension of array. So we can use directly this particular function to get that particular value, so that we didn't need to hard code that value. Okay, so moving on to the next built-in functions, I will cover this percentile error later with file built-in functions. Over here, these are the two built-in functions like percentile hours, percentile minutes, and also you can use the percentile seconds as well. So this can be used whenever we want some operation on time, means we want to add some hours into time, we want to subtract some hours or minutes or seconds, then we can use these hours, percentile minutes, and percentile seconds built-in functions. So let's suppose over here in the time zero variable I have value as 10, 12, 15, and I want to add 4 hours. So after executing this particular statement, we get 14, 12, 15. So I have added 4 hours in the time variable. So whenever you want to do that kind of calculation, like you want to add some duration in time, then you can use these three built-in functions. Okay. So moving on to the next built-in functions, which is percentile scan. Percentile scan built-in function is similar to the scan opcode that we have studied recently in opcode session. So percentile scan built-in function will search the value into the first parameter in the string that we will be passing the second parameter, and the third parameter is we can give the starting position from where we want to start our searching. So over here, in the source we have stored as search string, and if I want to scan the value of blank in the search string, then I can use this built-in function percentile scan. In the first parameter I have passed blank, in the second I have given the source string, and I haven't given any starting position, so it will take it from the first position itself. So after executing this, we will store the position of this blank in POS variable. So we get that variable over here. Now the second built-in function is percentile replace. If we want to replace some value into the string, then we can use this percentile replace built-in function. Like in the, it is also having like 4 parameters. First is like replacing string which we want to replace, second is the string in which we want to replace that string, and third one is the starting position from where we want to replace it, and then the third one is last one is offset, like how much variables we want to replace. See over in this example, I have found the position of blank in search string. So now I want to replace word in source string from position. Position plus 1 means from this position, 8th position, and only the 6 characters. So 6 characters are string. So I want to replace this string with word. So we can use this percentile replace built-in function to do the same. So after executing this statement, we will get the result as search word. And earlier we had value of source as search string. So I have replaced that string with word. So you can use this particular built-in function while uh, replacing some part of a s- character variable. Okay, so this is about percentile scan and percentile replace built-in functions. Moving on to the next built-in function, which is percentile substring, and its syntax is like source string and then starting position and the length that we want to extract from that particular string. So percentile substring built-in function will return us a substring, and we have to pass the starting position and the length of that particular substring that we want to extract from the string. So let's suppose over here in the name variable I have stored this Praveen Rana. Now I'm checking the non-occurrence of blanks in name. So I will get the value as 19 of a. Now I have substring that value of name from first position to the position. So position is 19. So I will retrieve all these 19 characters and will store those in name one. So after executing this statement in the name one, I will get the value as Praveen Rana, and as the name one is having length has 30, so we are seeing all these blanks. So this percentile substring is used to get a substring from a string, and we have to pass the string variable, then the starting position of the substring, and the length of that substring that we want to extract. So this is it about the percentile substring function. So moving on to the next built-in function, which is percentile timestamp. And this built-in function is used first if we want to get the current timestamp value, and the second is if we are having a character variable, and if in that character variable we are having a timestamp value, so we can use the percentile timestamp built-in function to convert that character variable into the a type of timestamp value. So let's see the results over here. In the first, I'm getting the current timestamp, and in the times, if you will see over here, currently we are getting this value only, and after executing this statement in the times, it will store the current timestamp. Okay, and this time is of the system time only. Now in the second example I have shown, like if I'm passing a character into this percentile timestamp built-in function, then it will convert it uh, into a timestamp variable, and then it is storing it into this time as variable, which is of timestamp. Okay, so it has converted that into timestamp, and I can show you like its data type. It's of z, which is of type timestamp. Okay, so yeah, so next built-in function is trim. These are three built-in function like percentile trim. These are being used to trim the values from a character string. If we are using percentile trim, then it will trim the values of that particular string from both of the side, from left and right as well. But if we want to trim from the left side itself, then we can use the built-in function percentile trim L. And if we want to trim the values from the right side, then we can use trim R. And what kind of values it can trim? You can specify that particular character, like you can trim the blanks, you can trim the zeros, you can trim any kind of uh, character that you will give here. So here I have shown you the examples of trim. In the input char variable, I have this value, and if you see in the right side, we are having blanks. And after executing that statement, we can store that value. Means if this particular trim char variable is of length only this, then it will store only this. But I have the length of this variable as same as this, so it has not, you can see the effect of that particular built-in function. So now I'm showing you this. In this particular example, I want to trim 0 and blanks from both sides. So, and in this particular variable time char, input char, sorry, we are having values as dollar, then stars 5.25, then star star, and then 000, and then all these blanks. So it will trim all these values and store the result in trim char. If I will execute this statement and will see the result in the trim, those zeros has been removed, and as its length is more than this particular variable, so it's showing the blanks in the end. Now if I want to remove these 0, space, and stars, then it will remove all these from this particular input char. And if I will show you the result in trim char, we are having only this 5.25 only, and all the stars, zeros, and blanks has been trimmed. Okay, now if you have seen, like, stars are not removed from here, so it will stop only at that particular place where it doesn't find the first occurrence of that character. Like, first character it found dollar, so it has not replaced these stars after that. But if I have mentioned over here, I want to replace 0, then blank, then star, then dollar, so it will replace all these, and only it will store 5.25 in trim char variable. If you will see here, the input char variable is having value as this, and once I will execute this statement, trim char will having only value of this 5.25, because we have trimmed all these characters from this particular variable. So after executing this statement, you can check this. Trim char is having value of 5.25 only, and all those characters has been trimmed from this particular character variable. Now moving on to the next built-in function, percentile trim L. So it will trim from the left side only. So in the first one, you will not be able to see the results. So I have taken the next example. So I'm jumping on to that one. So I want to trim these blanks and dollar from the left side. So it will replace this dollar, and we don't have any blanks here. So after executing this, we are storing this star 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 52.5 and all these values, and it has just trimmed those, that dollar and spaces from the left. And same we can do from the right side. And moving on to this example, in this example I want to trim, I am trimming the values of blank and zeros from the right side. And in input char variable, we are having value this, so these blanks and zeros will be trimmed from the right side only. So after executing this statement, you can check the result. These zeros has been removed, trimmed from this particular string. And yeah, so now I'm done with that particular built-in function. Now I'm moving to the next built-in functions that are being used with files. Okay, so here I have a file empf, and I'm I want to open that file, handle that opening and closing of that file inside my program itself. So these are the built-in function that can be used to check whether a file is opened or not. So I can check that by using this particular built-in function percentile open. Percentile, by using that percentile open function, we can check whether the file is currently open or not. And if that file is not open, then you can open that file. So in the first statement, I'm checking that if not percentile open means if file is not open, then I want to just open that file. Let me compile this program again. Hmm. See, now I'm opening this file again. Yeah. Hmm. I'm just going through that particular program by showing you code itself. There is some error coming on, so I will remove that and then just show you the example later on. Here, if that particular file is not open, then we can just open that file by using this opcode open. Okay, and then there is another built-in function which is percentile equal, that is being used with setll opcode. And by using that percentile equal built-in function, we can check that whether that particular record exists in the file or not. Here I'm checking the record of employee ID 104 in file empf exists or not. If it exists, then this uh, settle opcode will turn this percentile equal built-in function on, and we will move into our next statement over here. And if it does not find that particular variable, then it will skip all the um, things inside this if and if block. Okay, if I found this value, then I'm moving on to the next built-in function, which is percentile found. We can check whether a value exists inside a file or not by using this chain opcode. And if that is found, then this particular built-in function will return on. So we can execute some statements inside that particular if and if block. So we can use this percentile found built-in function to check whether the result of this particular statement, uh, employee ID 104, exists in employee file or not. If it does exist, it will read that particular record, and it will just do the functionality inside if and if block. And in over here percentile equal, that particular opcode set ll, it doesn't read that value, it just checks whether that exists or not. So by using it, percentile equal built-in function with set ll opcode, we are just checking whether that particular record exists or not. And over here we are actually reading that particular file, that record of that file, so that we can do operation on that particular record. Moving on to the next built-in functions that are used with uh, our file opcodes is percentile EOF to check whether the end of that particular file comes or not. So let's suppose I am reading a file from the beginning. So I have set the uh, pointer on the beginning of that file by using the setll opcode with star lowell keyword. Now I am reading that particular file by using our read opcode. Okay, and over here in the statement do while, I'm checking whether that end of file comes or not, and if not, then I am just displaying the employee name over here, and I am reading the file again so that I can uh, read the next record. Okay, so over here it will read all the records till the end of file, and once end of file comes, this indicator will turn on and we will be exiting from this do while loop. Moving on to the next is we can also use percentile error built-in function with read opcode, and like if that particular record is being used in some other program as well, like that 104 employee id record is being used in some other program as well, then once it will come to this statement to read that particular record from the file, then it will throw an error because that particular record is locked by some other program. So it will, to handle that particular error, we can use this opcode extender e, and we can check that by this condition if percentile error. So built-in function percentile error will turn on, and we can check that like this is another built-in function that we can use with file percentile status. What percentile status returns? It returns us a code like this 01218 code that I have used. It tell us whether the record is being locked or not. So if that record is locked, I can check that by mapping it like if percentile status equal to 01218. So percentile status, if it has returned the value 01218, so it will execute the next statements. So we can use this percentile status to just check what kind of error has been thrown by this read opcode. And on the basis of like what kind of status code it has written, we can write some statements to handle that particular kind of error. After that, I have used just that percentile open statement, open built-in code to just close the file. Like if the file is open, then I want to just close the file. So this is all about those built-in functions that I have taken today. So I'm done.
So that is all about today's built-in function session. And now if you have any query regarding this session or any session, then you can type in chat box. So thank you for joining today's session. You can join clinical session as